In this Machine Saver Minute, we explain what is the MODBUS protocol and why we use MODBUS. In the 1940s, simple mechanical vibration switches were used to activate an on-off relay, which would shut the machine down if the switch detected a strong mechanical shock. This mechanical device had limited success because it would turn off the machine without any warning. This technology might prevent a near miss, but the damage to the machine was catastrophic. The 4 to 20 milliamp convention was born in the 1950s out of the earlier, highly successful 3 to 15 psi pneumatic control signal standard. The 4 to 20 milliamp output was introduced to the machine vibration world in the late 1980s. This was a step up from the go, no-go mechanical vibration switch because now the operator, maintenance personnel, and reliability engineers could see the 4 to 20 milliamp output creeping up over time as the machine's mechanical condition deteriorated. The two main drawbacks of the 4 to 20 milliamp output are each device must have its own separate pair of wires going from the transmitter back to the receiver, and the 4 to 20 milliamp output can only represent one piece of information in range. An example would be a transmitter that gives off the vibration for a horizontal velocity from 0 to 1 inch per second at full scale. The MODBUS protocol messaging structure was developed by MODBUS in 1979. Used to establish client-server communication between intelligent devices. It is the most widely used network protocol in the industrial manufacturing environment. For vibration monitoring, it is called out in many industry specifications like API 670 machinery protection systems. The intelligent tri-vibe device can return many useful data points for the operator, maintenance, and reliability engineers. Also, MODBUS wiring is one data cable chained from one intelligent device to the next, back to the MODBUS receiver or master, enabling many sensors to be connected to this common bus. This is important because the wiring is often 30% of the cost of an installation. Also, since the tri-vibe power is carried on the cable, the tri-vibe is maintenance-free with no batteries to swap out periodically. The tri-vibe sensor can carry a huge amount of useful data in milliseconds back to the receiver or MODBUS master. Some of the data a single sensor can provide is bearing temperature, x-axis acceleration, y-axis acceleration, z-axis acceleration, x-axis velocity, y-axis velocity, z-axis velocity, high and low pass filter information, mechanical impact counts, mechanical severity level, sensor status, and much more. More valuable information to protect and monitor your equipment means you can keep those machines up and running and your company more profitable and safe. Machine Saver, the solution before the problem.